So we have covered nodal analysis and mesh analysis for DC circuits. When we'll be studying AC circuits, we'll be applying nodal analysis and mesh analysis there also. Also, we have actually only used nodal analysis, mesh analysis for resistive circuits so far. So, and we'll be taking AC circuits, we'll be using inductors, capacitances, etc. as well. Uh, so, with inductors and capacitors, how to apply nodal analysis, mesh analysis, we'll be seeing there as well. Now, moving on, still talking about DC circuits, we'll be now studying basic circuit theorems. We have to study four theorems, the superposition theorem, the Thevenin's theorem, the Norton's theorem, and the maximum power transfer theorem. So these four are actually widely used in both DC as well as AC circuits. And each and every theorem has a significance, has its own role to play. But before that, we need to understand that these theorems are applicable mainly to so most of these theorems are applicable to linear circuits only. Linear circuits. So we need to actually first of all define what is a linear circuit. Linear circuit or a linear system in general we'll be defining. So one way of defining linear system or a linear circuit is where input and output have a direct relationship. So that means your output is uh, directly proportional to the input that you are applying. So if you are applying an input of X, your output is directly proportional to it. So this is one way of defining a linear circuit. Uh, but we define linear systems or linear circuits as a system which obeys two principles. These principles are additivity and homogeneity. Any linear system is defined as a system which obeys two fundamental principles of additivity and homogeneity. Additivity is sometimes we also say this as superposition and homogeneity. So इसका मतलब क्या है? So if we are applying an input x1, we are applying an input x1 to a system, it produces an output y1. Uh, and if we are applying an input x2 to a system, same system, it is producing an output y2, the same system. Then if to the same system we apply x1 plus x2, it should produce an output of y1 plus y2. So this is the principle of additivity. If you are applying an input x1 to a system and it's producing an output y1, and if you are applying an input of x2 to the system, it's producing an output of y2, then if x1 plus x2 is applied to the system, it should produce an output of y1 plus y2. Secondly, if we are applying an input of x to the system, it is producing an output y. Then if we apply an input of alpha x to the system, it should produce an output of alpha y. Fine, this is known as homogeneity. तो आप एक सिस्टम को इनपुट x दे रहे हो, it's producing an output y. So if you scale it by a constant term of alpha times x you are applying to the system, then it should produce an output of alpha times y. So if these two principles are obeyed by any system, then such a system is known as linear system. So uh, we have a basic example wherein we have a simple resistor circuit. Say for example, we have a 5 ohm resistance. Fine. So we are applying an input of V and it's producing an output of current I. Fine. So V here is the input, I is the output, and the system is this resistance whose value is R equal to 5 ohms. So if we apply, say for example, 20 volts to this 5 ohm resistor, how much current will flow through it? I is equal to V by R, that is 4 amperes. Fine. Now if we apply an input of 30 volts to this 5 ohm resistor, how much current will it produce? I is equal to 30 by 5, that is 6 amperes. Now if we apply a combined input of 50 volts to this 5 ohm resistor, then it should produce an output of I equal to 4 plus 6, that is 10 amperes. And we can actually see that from Ohm's law, because 50 divided by 5 is also equal to 10 amperes. So this principle holds here. Additivity holds here. That is, if we are applying an input of say some x volts to a resistance of fixed resistance of R equal to 5 ohms, then we are having an output of we are producing a certain output. Then if we are applying a different input to this system, it's producing a different output, but combined input will produce a combined output. तो ये तो एक केस हो गया. Similarly, ये तो additivity का केस हो गया. Second is homogeneity. In homogeneity, if we are applying an input of say for example 10 volts to this 5 ohm resistor, the current flowing will be 10 by 5, that is 2 amperes. Fine. Now if we are multiplying and applying an input of say for example 15 volts to this circuit, to the same 2 ohm circuit, and what should be I? That should be 1.5 into 2, that is uh,
3.
1.5 into 2, that is 3. So आप देख सकते हो कि if you are applying 15 divided by resistance 5, that is also equal to 3 ohms. Fine. So you can see homogeneity as well as additivity holds true for a resistive circuit. So V and I, they have, you will say that V and I have a direct relationship, or you can say V and I are linear with respect to each other. This is true from Ohm's law also. Now अगर हम power की बात करें, power across this resistance, P is equal to I square R is the formula for power across this resistance. So if you are applying, for example, we are taking a resistance of 2 ohms. Now here, let us say I is the input and P is the output. Fine. So for example, if you are applying an input current of 2 amperes, a 2 ampere current is flowing through this resistance. For 2 amperes case, what will be P1? P1 will be equal to 2 square into resistance is also 2 That means 4 square into 2, that means 8 watts. For say for example 3 amperes, P2 will be equal to 3 square into 2, that is 9 to the 18 watts. So if linearity principle had to hold true, that means for 5 amperes the total power should have been 8 plus 18, that is 26 watts. Fine. But what we see with 5 amperes is P3 will be 5 square into 2, that is 25 into 2, that is 50 watts. So P3 is not equal to this, uh, it does not hold additivity. So even if one of the principle fails, you will say that such a system is not linear, or such a relationship is not linear. Okay? So power versus I in this case is not a linear relationship. वो तो आप डायरेक्टली इक्वेशन से भी बता सकते हो, but sometimes we may have to find out. If we do not know the equation, we will have to find out using certain other techniques. तो आपको अगर किसी भी linear system को देखना है, if you want to find out any system whether it is linear or not, this is for any system in general, and now we are applying it to circuits also. You have to, the linear system should hold the property of additivity and homogeneity. तो ये तो अब हमने डिफाइन कर लिया कि अब लीनियर सर्किट क्या होता है. अब हम थ्योरम्स पे आते हैं. ये हमने क्यों पढ़ा लीनियर सर्किट? व्हाई डिड वी अंडरस्टैंड linearity properties? Because of the fact that these theorems are only applicable, most of these theorems are only applicable to linear circuits. We'll be starting with the superposition theorem.
एक्सक्यूज मी सर.
Yes.
सर अगर हम P इक्वल्स टू VI से करेंगे तो
Then P और V के बीच में आप बोल सकते हो कि आपकी एक लीनियर रिलेशनशिप है, बट उसमें सिस्टम कौन सा है? P इक्वल टू VI में सिस्टम कौन सा है? P इक्वल टू I स्क्वायर R में एक सिस्टम है आपके पास. R इज एन एलिमेंट जिसके अक्रॉस आप एक करंट फ्लो कर रहे हो, पावर डिलीवर कर रहे हो. R विल एक्चुअली रिप्रेजेंट अ लोड. तो R विल रिप्रेजेंट अ सिस्टम जिसको आप फीड कर रहे हो. P इज इक्वल टू VI, दैट कर्व मे बी लीनियर, बट उसमें कोई सिस्टम तो है नहीं. P इज इक्वल टू VI में सिस्टम कौन सा है?
सर हम ये निकाल सकते हैं ना, मतलब पावर डिलीवर्ड बाय द
You can say
एलिमेंट.
at the load and have the source and whatever is power delivered, that may be linear. और जो आपका लोड एंड पे जो सिस्टम है उसमें जो पावर फ्लो हो रहा है, that is non-linear in nature. That has a non-linear characteristics. पावर और करंट के बीच में जो कैरेक्टरिस्टिक्स है वो नॉन लीनियर है. ठीक है. तो आपकी पर्टिकुलर इक्वेशन नॉन लीनियर है. आपका पर्टिकुलर एक सिस्टम जो होता है, आप सिस्टम को बोलते हो एक्चुअली वेदर इट्स लीनियर और नॉट लीनियर. तो आपका सिस्टम है यहाँ पे, वो आपका लोड होगा, वो रेजिस्टेंस से डिस्क्राइब होगा. सो दैट विल बी नॉन लीनियर. योर सिस्टम इज नॉन लीनियर.
ओके सर, गॉट इट. सर
यस.
सर वी हैव पैरेलल सिस्टम सर, मींस पैरेलल एलिमेंट,
यस.
देन voltage will be same, so we can have a direct relationship P and I,
बिटवीन
linear P and I,
P
P
and
is
I.
equal to VI and voltage will be same sir.
Voltage को, what I am not sure what
और
we have to do
parallel
with voltage in the, if we are talking about power consumed by a resistance, that is I square R. So you will be applying P is equal to I square R relationship there. So power consumed by a resistance is a non-linear equation. ये simple है, इसमें कोई दो राय नहीं है. Power and current relationship is non-linear. ठीक है. You may find out power with some other element may be linear. Power versus voltage may be linear, but power and current की जो relationship है, that is non-linear for a resistor. It also depends upon the system. ठीक है. किसी और element में हो सकता है power और current के बीच में linear relationship भी हो. ठीक है. तो resistor के केस में P is equal to I square R, it is non-linear. Power and current relationship is non-linear. पावर और वोल्टेज की बात यहाँ पे नहीं हो रही है, पावर और वोल्टेज के बीच में हो सकता है लीनियर रिलेशनशिप हो। पावर, ये तो बस मैं एग्जांपल दे रहा था। Power on current relationship, that is the volt power consumed by a resistor, is having a non-linear relationship. Now, superposition theorem, it is applicable to linear circuits only. Now, what does this theorem state is that if you have a number of you have a circuit which has a number of independent sources. Now, these we are talking about only independent sources, not dependent sources. Say, for example, you have a circuit like this. You have voltage source V1, you have voltage source V2, you can have many more voltage sources, you can have current sources as well, fine. So if this circuit has a number of independent sources, so the voltage or current, now the voltage or current through any element is, say for example, we are talking about the voltage or current across this particular element. Let me draw more resistances here, R1, R2, R3. Say for example, voltage across this is V, current flowing through this resistance R3 is I. The voltage or current through any element is summation of voltage or current respectively the voltage or current through any element is the summation of voltage or current again respectively through that element taking each independent source individually. ठीक है, तो इसका क्या मतलब है, आपके पास एक सर्किट है, इसमें बहुत सारे वोल्टेज सोर्सेज हैं, इसमें बहुत सारे हो सकता है करंट सोर्सेज भी हों. फॉर एग्जांपल यू हैव करंट सोर्स आल्सो हियर. नाउ इफ वी आर टॉकिंग अबाउट वोल्टेज और करंट थ्रू एनी पर्टिकुलर एलिमेंट, हमें खाली एक पर्टिकुलर ब्रांच में से करंट निकालनी है, बाकी सर्किट के साथ हमें कोई डीलिंग नहीं है. So it is better to apply the superposition theorem. So what does superposition theorem state that? What you have to do is you have to take each individual voltage source or current source one at a time and see what will be the contribution of that voltage source through that particular element. Uh, so once you find out contribution of each and every individual independent source, फिर उनका summation करना है, you will get the net result. That means आपके पास बहुत सारे voltage sources थे, current sources थे, you will simply turn off this voltage source, you will turn off this current source, you will see what will be contribution of V1 through this resistance R3. Let contribution of V1 through resistance R3 be I dash, fine. Then you will turn while V2 and I1 they are turned off. Then you will see contribution of V2 through this particular resistance R3, let that be I double dash. So ये कब निकालेंगे हम, while we'll keep V1 and I1 turned off or switched off, right? Similarly, then you have to find out the contribution of the current source, let that be I triple dash, while V1 and V2 are turned off. तो आपको एक एक करके लेना है, आपको एक वोल्टेज सोर्स लेना है, तो यू हैव टू फाइंड आउट व्हाट विल बी द करंट थ्रू दिस पर्टिकुलर ब्रांच. Fine. Then you have to take another voltage source. You have to see what is the current through this branch. Then you have to take another voltage source or current source, whatever is in there in that circuit. You have to see what is the current. Then the total current that is actually flowing with all the three present together, I will be equal to I dash plus I double dash plus I ट्रिपल डैश. ठीक है, ये ऑलमोस्ट सुपरपोजिशन की जो एडिटिविटी प्रॉपर्टी है, लीनियरिटी की जो एडिटिविटी प्रॉपर्टी है, दिस इज सिमिलर टू दैट. So you are taking input x, you are finding out output y, you are taking in x1 के पास y1 है, x2 के पास y2 है, x3 is giving an output of y3. So you are finding the total contribution of all the three by simply summing out the outputs y1 plus y2 plus y3. In this case, that's I dash, I double dash, I triple dash. Now you can do with this with every element. You can take वोल्टेज और करंट अक्रॉस रेजिस्टेंस R2. ठीक है, ऐसे ही वोल्टेज भी आप निकाल सकते हो. से फॉर एग्जांपल V1 has a contribution of V dash across resistance R3. V2 has a contribution of V double dash across R3. I has a contribution of V triple dash across I3. So total voltage that will be present across this resistance will be V1, V dash plus V double dash plus V triple dash. So this is superposition theorem. Now what does turning off here mean? Say for example, I have this simple circuit R1, R2 or R3, three resistances है. You have one voltage source, you have one current source. Uh, so you want to say for example find out this small I, that is current flowing through this resistance R3. Now you can solve this using nodal analysis or mesh analysis. That you can apply that, but you can also apply superposition theorem. Now to solve for this small I, if you want to find out the small I, you can also apply superposition theorem. So what will superposition theorem state is, by applying superposition theorem, you have to take contribution of each and every individual voltage and current sources, then sum that up. So what you will do is, say for example, first we will uh, turn off this current source and keep this voltage source on. Turning off the current source means voltage source तो on ही है. Turning off means make this current I equal to 0. So when will current I be equal to 0 in a circuit is when it will be open circuited. So you will open circuit the current source. So once you have open circuited the current source, so यहाँ से जो current flow हो रही है उस time पे that let that be I dash. Now you can easily solve this circuit क्योंकि यहाँ से कोई current flow नहीं हो रही है R2 से. You can simply say I dash is equal to V divided by R1 plus R3. Fine. So ये तो I dash आपका मिल गया. Second step is now turn off the voltage source. So ये आपकी resistance है R1. This is step 1. This is step 2. Now keep the current source on. Turn off the voltage source. Turning off the voltage source means making V equal to 0. V कब 0 होगा? जब आपका circuit short होगा. So making V equal to 0 means short circuiting it. Making I equal to 0 means open circuiting it. तो यहाँ से current से for example I double dash है. ठीक है, तो I double dash यहाँ पे आप सिंपली करंट डिवाइडर लॉ लगा सकते हो. I into R1 divided by mm, R1 plus क्योंकि यहाँ से करंट I फ्लो हो रही है, तो I डबल डैश विल बी सिंपली इक्वल टू I इंटू R1 डिवाइडेड बाई R1 प्लस R3. तो ये आपकी I डैश होगी. तो जो अब टोटल करंट होगी that will be simply equal to I dash plus I double dash. So this is what superposition theorem will give you. Fine. Turn off each independent sources one at a time, not one at a time, keeping only one on at a time. बाकी जितने भी होंगे सर्किट में उन सबको ऑफ करना है, एंड देन
सर
फाइंड
आई
आउट
सर आई डैश फिर से बता दीजिए.
आई डैश.
यस सर.
क्योंकि यहाँ से कोई करंट फ्लो नहीं हो रही है, यहाँ पे नेट रेजिस्टेंस इक्विवेलेंट रेजिस्टेंस इज सिंपली R1 plus R3, so I dash will be simply voltage divided by resistance R1 plus R3. It is
ओके सर.
as good as this. इतना ही सर्किट है अब, क्योंकि यहाँ से ओपन है, इतना ही सर्किट है. So I dash is simply V divided by R1 plus R3. So with superposition theorem, keep one source on at a time, turn off all other independent voltage sources or current sources, then find out contribution of each and every independent source individually, and then the total current or voltage across that element will be simply the summation of current oblique voltage taken individually at a time.
Sir, we in the previous question were we finding the total current in R3?
Yes.
Okay. Okay.
ये आपके पास सर्किट है, इस you are finding out this current I. You can find out using nodal analysis or mesh analysis. You can also apply simply superposition theorem. With the superposition theorem, it becomes fairly simpler. Use superposition theorem to find V. Your circuit is you have a 6-volt source here, you have an 8 ohm resistor here, you have 4 ohm resistance here, you have a 3 ampere current source here. So V जो है voltage, that is this voltage. You want to find out this V, that is the voltage across this 4 ohm resistance. Uh, you can make use of nodal analysis, you can make use of mesh analysis. आप किसी से भी कर सकते हो, but यहाँ पे specifically the question has asked us to solve this using superposition theorem. तो superposition theorem में क्या करना है? Take one independent source at a time, बाकी sources को turn off करना है, find out V dash, find out V double dash, then V will be equal to V dash plus V double dash. So first we'll take the voltage source, 6 volts, ये 8 ohms है, ये 4 ohms है, this is 8 ohms, this is 4 ohms. यहाँ से जो 3 एम्पेयर ये ओपन सर्किट हो गया अब यहाँ से, ठीक है, 3 एम्पेयर करंट सोर्स को हमने ओपन सर्किट कर दिया. This is suppressing the current source or turning off the current source. Now let the voltage across this be V dash right now. So what will V dash be equal to? 6 into 4 divided by 4 plus 8. That is 2 volts. Fine. So step 2, this is voltage divider law. Uh, turn off the voltage source now. That means short circuit it. This is 8 ohms. This is 4 ohms. This is 3 ampere This is V double dash. To find out V double dash, let us first of all find out the current through this path. Let that be current be I. यहाँ से जो current है वो 3 amperes है. So I is equal to 3 by current divided by law, 3 into 8 divided by 8 plus 4, 24 divided by 12, that is 2 amperes. 2 amperes current यहाँ से flow रही है. That means V double dash is 4 into 2, that is 8 volts. Fine. So V double dash भी हमारा हो गया. तो total V किसके बराबर है? अब simply V dash plus V double dash, that is 2 plus 8 equal to 10 volts. Is this clear?
Yes, sir.
So it is much easier to solve this instead of going for nodal analysis or mesh analysis. It's much easier to solve this taking one independent source at a time. This is only applicable to linear circuits. That means आपकी जो resistor है, we are assuming that these are all linear resistors.
पर अगर डिपेंडेंट सोर्सेस होगी तब
Dependent sources, हाँ वो भी हम numerical कर लेंगे फिर. Dependent sources को turn off नहीं करना है, उसको on ही रखना है. This is 4 amperes, this is 3 ohms, ये आपकी होगी 5 ohm resistance, 1 ohm, this is 5 I naught. I naught is the current flowing through this 5 ohm resistance. ऊपर से आपकी 2 ohm resistance है. This is 4 ohm resistance. This is again 20 volts. So you have to actually find out I naught using superposition theorem. So apart from independent sources, you also have a dependent source here. Dependent source, you need not turn it off. You need to only turn off the independent sources, whether it's voltage or current source. So let us first of all turn off, or you can say suppress the 20 volt voltage source. So हम step 1 करेंगे. That means you have a 4 ampere current source. You have 3 ohms here. You have 5 ohms here. 20 ampere को 20 volts हमने suppress किया. 1 ohm. This is 1 ohm plus minus. Turn off the 20 volt voltage source. Fine. So we have turned this off by short circuiting the voltage source. Now let the current that's actually flowing through this path be I naught dash. So if this is I naught dash, ये जो dependent source था इसका value 5 I naught था, ये भी 5 I naught dash बन जाएगा because it depends upon the current that's actually flowing through this 5 ohm resistance. So now you have to solve for I naught dash. So अब आप जो भी method use करना चाहो, you can apply that and solve for this I naught dash. Give me the value of I naught dash quickly. This is step 1. Okay, you can apply mesh analysis now or nodal analysis and find out the value of I naught dash. I naught dash कितना आएगा?
4/5 ampere.
I naught dash by mesh analysis. नहीं, 4/5 नहीं आ रहा है.
Sir, 4/25. Sorry.
No.
Okay. 4/15.
No.
Sir, 52/17.
So you can apply mesh analysis and you can find out the value of I naught dash. That will be 52/17 amperes. Dependent curves को कुछ नहीं करना है. It remains on. With now you have to turn off the 4 ampere current source. That means it's open circuited. So your circuit simply is like this: 3 ohms, 2 ohms, 1 ohm, 5 ohms, 4 ohms. This is 20 volts. So let current now be I naught double dash flowing from here. So this will be 5 I naught double dash. So again, you can use mesh analysis or nodal analysis, whatever you want to do, and find out the value of. It's better to have like simply mesh analysis. Find out the value of I naught double dash.
Sir, minus 60/17.
So I naught will simply then be equal to I naught dash plus I naught double dash. That is 52/17 minus 60/17. That's minus 8/17 amperes. So ये आपका सर्किट है. You have a 6 ohm resistance. You have 2 ampere current source. $20, 1 ampere, 3 ohms. V0 is the voltage across this resistance. This is 4 ohms. This is 2 ohms. Fine. So step 1, you have 3 sources here, 2 ampere and 1 ampere. So turn off 2 ampere and 1 ampere current sources. Find out V0 dash. Find. Step 2, turn off 20 volt and 1 ampere current source. V0 double dash. And third step, turn off 20 volt and 2 ampere voltage source and current source. So find out V0 triple dash. Fine. So पहले केस में आपका सर्किट 6 ohms ऊपर से 2 एम्पेयर करंट सोर्स को आपने टर्न ऑफ कर दिया तो ओपन सर्किट हो गया. ये आपका 6, 4, 2, यहाँ पे 20 वोल्ट है, वो भी ओपन सर्किट हो गया. यहाँ से 3 ohms है. So V0 dash को पहले, this will be V0 dash. You have to obtain this, turning off the current sources. In the second case, you have to keep 2 ampere current source on. This is 6 ohms. This is 2 ampere current source here. This is 4 ohms. This is 2 ohms. This is 3 ohms. 1 ampere करंट सोर्स को ओपन कर दिया, 20 वोल्ट को शॉर्ट कर दिया, तो ये आपका सर्किट हो गया. दिस इज V0 डबल डैश. थर्ड केस में दिस इज 6 ohms, 4 ohms, 2 ohms, 6, 4, 2, 2 एम्पेयर करंट सोर्स को हमने ओपन कर दिया, 20 वोल्ट को शॉर्ट कर दिया. दिस 1 एम्पेयर करंट सोर्स इज देयर नाउ. ये 3 ohms है. V0 triple dash. Give me the values of V0 dash, V0 double dash and V0 triple dash.
सर फर्स्ट में 10 होगा V नॉट डैश का वैल्यू.
Yes, sir. 10.
V naught dash is 10 volts. Fine. V naught double dash.
सर दो सोर्सेस को पेयर में टर्न ऑफ रखना जरूरी है, सिंगल सिंगल टर्न ऑफ नहीं रख सकते हैं.
You have to turn off all the sources. You have to keep only one source on at a time.
So you are turn off two at a time.
In this case, you have to turn off two at a time. Yes, V naught double dash.
Sir, is it
Sir, 3 volt.
volt?
V naught double dash. 3 तो है but -3 है.
-3, sir.
Yes, sir. Minus.
V naught triple dash.
Sir, is it 25 and 9?
No.
Sir, 2 volt.
No.
Sir, 2 volt.
No. No. V naught triple dash will come out to be 1 volts. You can use nodal analysis to check it out. So total V naught will be 10 minus 3 plus 1, that is 8 volts. ठीक है, तो मैंने आपको सोर्स ट्रांसफॉर्मेशंस भी पढ़ाया पहले ही. सो इफ एनी सर्किट इज नॉट पॉसिबल टू सॉल्व, अगर एक कोई सर्किट कॉम्प्लेक्स हो जाता है, जैसे आपको यहाँ पे नोडल एनालिसिस करना पड़ेगा टू सॉल्व दिस, and you do not want to do that, you can apply source transformation at any time. ये जो आपकी करंट सोर्स है और ये जो आपका 4 ohm resistance है, they are in parallel, so you can transform them into a voltage source in series with this resistance. So this circuit will simply look like this. After transformation, this circuit will look like this. 6 ohms तो ऊपर ऐसे ही है. 4 ohm resistance and 1 ampere current source, they are in parallel. So total voltage now that will be produced is 4 volts, and जो resistance है 4 ohms वो ऐसे ही रहेगी, और ये जो 2 ohm resistance है अब ये भी इसके साथ सीरीज में आ गई. यहाँ से आपकी 3 ohm resistance है. ये आपका सर्किट हो गया. Now we can easily find out V naught triple dash here by clubbing this 4 ohm and 1 ohm that are in parallel. You can transform them into a voltage source in series with the same resistance. Voltage source का जो value होगा simply I into R, that is 4 volts. Now it will be much easier for you to solve for V naught triple dash with this circuit. With this original circuit, you could have also solved for V naught triple dash using nodal analysis. If it becomes complicated, you can always go for source transformation. Source transformation जहाँ पे भी आपको लगे कि it becomes easier for me to solve with the source transformation, you should always go for source transformation. Fine. So that will be all for today. Do more numericals on superposition theorem. Practice this, and as well as source transformations जहाँ पे भी आप देख पाओ हो सकती है. With that, if it is possible for you to easily solve any circuit, do that. Is it okay?